Hey guys, I'm extremely excited to post this video because I think this is a really cool idea and just a really cool tutorial. So basically what I'm going to be showing you is how to make a mine that explodes, but it can't actually reach you through a wall. But the way the mine works, you just walk on it, it explodes like normal. I made my own little explosion effect, nothing too special, just quickly came up with it. And I even made it so you could, like this red mine for example, it's like a mega mine, so it actually has a bigger explosion radius. And I made this using object-oriented programming and also did raycasting, or used raycasting. So I'm going to be showing you how to make these mines using raycasting and also object-oriented programming. Before that, I want to show you one more thing. So these mines do not actually damage you through walls. So let me show you what I mean by that. So these have like a pretty large radius of explosion. So let's just say a person walks on this mine. I don't get affected. But if I take this wall away, let me actually move this real quick. Right here, for example. And I'm like nearby. Bang, I still get damaged from it. So I'm going to be showing you how to make something like this. Very nice organized scripts. So there won't be a lot, well there will be a decent bit of code, but it'll be nice and organized and super cool. Alright, so let's jump right into the tutorial. So the first thing that I'm actually going to do is I'm going to get the mine instance. I'm just going to grab it from the example I showed you. I might make it like a little package so you could just grab it, or you can make one yourself. It's actually pretty easy. All I did was added some cylinders. As you can see, this is all the mine is, and a very off-center red cylinder in the middle. It's just a bunch of parts. There's no scripts in it, just a few welds. There's actually one script. And all the script does is kind of just makes this blink. They make it a little bit more center so it's not annoying. And yeah, so that's all that script does. But this has nothing to do with the explosion. It's purely cosmetic. So I'm going to be showing you guys how to make these mines actually explode when you touch it. And there's actually two ways we can make this. So in the example I showed you that I don't get damaged through a wall. The first way that I would think of would not be using raycasting. If I didn't use raycasting, I could just use magnitude to get the distance from the mine to the person, and that will actually make it so I can get damaged through the wall. But if I use raycasting, it will project a ray directly to the wall, it will hit the wall, and it will just not do anything because it already hit a part before getting to me. So we'll just stop the raycast and it will not damage me. So that will happen to all players. It will check if there are little obstacles in between, and if there are, you won't get damaged. So that's the idea of it, and I'm going to be using, like I said, object-oriented programming to make this. So let's get started with this. The first thing that I'm going to do is I am going to create a script, and this script I'm going to put into replicated storage. And once again, since I'm doing object-oriented programming, I'm going to use this, or use a module script for this. And I do have a tutorial on object-oriented programming. It's not like super practical, but I think it represents it in a good idea. So if you do want to go back, you could watch that real quick, get some prerequisite knowledge for this. So I'm not going to like fully go over how module scripts work again and stuff like that. Alright, so let's get started with this. So I'm just going to name this table mine. That's kind of what the module script is going to be named, because that's what we're making. We're making landmines. And once again, if you saw my tutorial on, I haven't made a tutorial on meta methods yet, but all I'm doing is just going to make this the dot index so I could use the functions inside this module. Okay, so next thing I'm going to do is just create the constructor. So this will just act as a object itself, the data that's within the object. And within this constructor, I'm going to have a table named self. And it's going to have a bunch of properties. These properties will define the mine. For example, how much damage the mine does when you step on it, the radius of damage it has, and maybe like a bunch of like other things like the connections, like the touch connections, for example. And of course, the object instance itself. So let's start writing this. So base damage, I just created a random number, 10. We'll just have it do 10 damage without like any changes. We'll have the blast radius also 10, and then mine is just going to be the object that's passed through as a parameter. So this is just so we have the object on hand, and that object I'm referring to is a physical in-game object. So this part in the game is going to be defined by this index. And the connection. So this connection is going to be a .touched event. So it will detect whenever someone touches this landmine. And that's how we know if it should explode or not. So I'm going to do that real quick. So object, this object right here, .touched, connect, function. So all I'm doing here is I'm just setting the connection equal to one of the properties of the table. And you know, if you don't know how .touched events work, every time an object, any game object, touches this part, it will fire whatever is inside the body of this function. And there's actually one parameter that will be passed through, and that is the object that is touching it. So I'm just going to name that hit. Alright, so just for testing purposes, I'm just going to have it print out what's touching it. And now we actually need to make like how it knows like what a mine object is and stuff. So what I'm going to do is go over to the workspace, and I'm going to add a folder instance. Just a folder, you know, nothing special. And I'm going to rename this folder to mines. This folder will hold all of the mine instances within the game. So every mine that I have, that's what's going to be inside the folder. So I'm just going to drag and drop this in here. And I'm going to add a script. So let me just remove hello world, we don't need that. And within the script, I'm going to make it so it basically iterates through the folder, all the children in the folder, and it's going to create an object. So it's going to call this mine.new function, and it's going to create an object for every mine that's in this folder. So to do that, I actually need to get this module script. So I'm going to do local rs. Rs is the replicated storage. That's where my module is. So I'm going to do game get service replicated storage. And then I'm going to get the mine module from replicated storage. Let's name it mine module. Require, and then it's just going to be rs find for child mine, because that's what we have it named, mine. And we're also going to have the folder defined. The folder is just this folder we have. So that's easily just script.parent. The parent of the script are the mines. And now I'm going to iterate through the folder. We do this by using a for loop. So I'm going to use this for loop to get all the children in this folder. So right now the only children in this folder is a script and this mine. Get children, do. So this will loop through all the children in the folder, and I just want to make sure I'm getting the parts. I do not want to get the script. The script is not a mine. So to do that, to avoid getting the script, I'm going to say if not mine is a script. So I'm just saying basically here, if the object that I'm on is not a script, then it's going to create a new mine. Mine module.new, and then simply this mine. Because again, this is a number and this is the actual object we're currently on. So we're going to create that new mine. So that's all we really need to do right now. And let's just test it. Make sure everything works. So if I play my game, let's see if any errors happen. Let's see if it actually runs. As you can see, we already got a little touch from the mine, and that's the base plate. See, every time I touch the mine, I get a body part printed out. Mainly my feet and my lower leg, because if you look, my feet are touching it. So that's why we're getting those outputs. Now all we need to do is have it do something. So let's do that. Let's have this connection actually do something. So I'm going to find the character that's touching the part. So hit. And by the way, you notice that it was always like my feet touching it and stuff like that, not my actual character. So I need to find the character's model from that. To do that, I'm going to type in find first ancestor. Finding the first ancestor is just like saying find the first instance which is of type model. And a model type is simply just this. And everyone's character is represented by a model. So we're going to grab that instance and then we're going to check if it has a humanoid or if it's even a model, if there is one. So if character, then making sure this model actually exists and it's not nil. Local humanoid. We'll have it just hum for now. Character find first child, humanoid. So we need to make sure this is actually a character and it's not just some random model that's in our game. So if humanoid, then this is where we're going to have our event that will fire. This will create the explosion basically. So I'm going to actually make a separate function for this. And this function, I'm going to create two separate functions. One's actually going to utilize raycasting and find all the players within the range. And the other is actually going to ignite the explosion. So let's get right to that. Oops. Function mine. And we're going to name this players in range. And I'm setting the colon here because I want to be able to see. I want to be able to use a self to get self, which is just the object which called the function. So we're going to have that and then range. Keep in mind, having the colon is basically the same thing if I were to put a period here and type in object mine. So I'm just not going to pass this through as a parameter. Instead, I'm just going to use a colon here, which automatically passes through self. And by the way, all of this is possible. Actually, that's speaking of which, I forgot to do this. Return, set metatable, and then the metatable is just going to be comprised of just self, which is this table, and the mine module right here. So then we can use all the functions, not just the parameters. Perfect. So now what we can do, remove this, because we do not need that. And then we're going to get all the players within the range. So I'm going to have a little table up here that just keeps track of all the characters that it touches. It's just going to store it so we can return it later. And then to get all the players, what we're going to do is we're going to actually, we'll identify a new variable up here. Players. Game get service players. So the player service, that's just this over here. So whenever I play the game, a player pops up in here. So basically what we're going to do is we're going to iterate through this list of players and we're going to get their characters. So that's what this does. So here we go. I'm going to type in mine because we want to make sure we have the mine object, which again we identified up here. And here's where we create the raycast. So the raycast has optional parameters which create like a little like whitelist or blacklist, whatever you want, which means objects can be avoided and not hit. So we're going to have one object that's not going to be hit, and then one object that we don't want to be affected by the raycast is this, the mine. We do not want the ray hitting the mine itself and just returning that. So that's no bueno, we're going to skip that. So what we're going to do is params, params, I spelled that wrong, that's my bad. Params dot filter descendant instances, and then we're going to name this just mine. So this will filter out the mine so we don't have to worry about the ray touching that. And then what else does a raycast need? It needs the origin position which is where the ray will be cast from, which is just going to be the mine, which we already have right here. We just need that position. And there's a second parameter, and that's the direction that's going to go in. So we're about to do that right now. So direction is equal to my character's primary part, which we actually we have to one thing I haven't been doing is I actually forgot to write the for loop. So let's do that real quick. So for I, comma, player and players get children. So it gets all the children here. Do. We'll indent this. So now I have every player. So what we do here, we're going to get the character from the player. Because we have the player, we can most definitely get their character. So that's perfect. And now we could get the direction. And by the way, I'm just going to take the position of my character's primary part, subtract that from the position of the mine, and get the unit. The unit vector is basically a vector of length 1. It's purely direction. Size does not matter. We do not need size right now. We're going to identify that within the raycast itself. So now we're going to actually cast the ray. So we do this by having a root part. We're going to use the workspace to cast the ray. And then we're going to type in raycast mine.position, comma direction, and just any number you want. We do actually have a radius function which will keep a range in check almost. I'm actually going to make this a further radius. Times self.radius. So now it will be a vector of length 50. Keep that in mind. And the third parameter, simply just the filter. So now the ray will be cast, and if the ray actually does not touch anything, it's going to return nil. So we're going to make sure that the ray cast actually hits something. We're going to do that. And to find what it hits, all we have to do is type in raycast.instance. This is the object that the raycast is hitting. And we're going to type in the model that's hitting. Hit, find first ancestor, which is a model. And then we want to make sure that the model is actually existent. And by the way, this is like the character, for example. We're just verifying that the character is getting hit from this. Then we're going to get the humanoid from that model. I typed in then twice. Look at that. Model, and then, oops, find first child, humanoid. Again, we're just making sure that the character has a humanoid. And if the humanoid's hit, we're going to add that character to this table. So we're going to do that by getting the length of the table and adding one index to it. Perfect. So this basically concludes this function. So now all we have to do is return the characters. So again, this function, to summarize it, it will get all the characters in the range and make sure they're hit, and it's going to return this table of characters. That's all it does. Next, we're going to have a function, and this is going to be the fun part, how it actually explodes. So I'm going to call this function inside of here because we left this body empty. All we want to do is call the function ignite. That's all we want to do. So now we go immediately down here, and we're going to disconnect that connection. We only want the part to be touched one time. If we do not disconnect this, we're at risk of having the explosion going off multiple times, because then it will be touched multiple times. So to prevent that, we're going to disconnect it completely. Alright, so what I'm going to do is, if you saw the particles that I had, I'm just going to copy those. Feel free to just completely make your own if you want. You could even use the one Roblox gives you. Explosion. Oops. You want to see that again? You could use this one if you want. It's up to you. Alright. So now that we got that, we're going to copy this into the module script, these two particles that I have. Oops, I'm not sure what I just did. I did something I didn't want to do. I tried pasting it, I accidentally deleted it. Definitely do not want to delete it, guys. That would be very bad. It's kind of weird. Put it in here. Okay. So now we got the two parts. Next thing we want to do is just refer to those within the mine script. Oops. So we're going to grab the smoke particles, and we're also going to grab the sparks particles. Perfect. So we're actually going to clone those. We don't want to grab the original copy or our script will break. We'll just get a bunch of errors because they don't exist. And then spark clone. Perfect. So what we want to do is have a new part that will hold these two clones. So we're going to do part.position equals self.mine.position. We're just going to put it at the position of the mine. That's all we want. And then what we're going to do after that is we're going to make sure that the part is actually parented to the workspace. We're going to make sure the part's anchored. And we're going to have the part be totally invisible, transparency of 1. And then finally we could just parent these smoke clones to the part. Spark clone equals part. And these are just visual effects, guys. Keep that in mind. VFX, that's all it is. Smoke clone dot speed equals a number range. This is like a little formula I came up with, nothing too big. It's just going to make it so it moves faster depending on the size of the explosion. Feel free to copy this, it's up to you. Times 5. And then we're going to use emit. Like this. I think this is a plugins function, I'm not quite sure. There's a plugin that I have that allows you to emit, but for now, if you need to install that, it's perfectly fine. I'll show you in a second what it is. So this will emit a certain amount of particles. So size, for example, we have actually we haven't even defined the size of our explosion yet. So we'll do that. The default size will make 5. That's perfect. That size times 100. So this will emit 500 particles. Seems like a lot. It's actually less than you would think. Alright. Let's keep going. So we're going to get the characters in range, and we made that function. So we're just going to grab that. And to make sure I have this, yep. And we'll get it within a range of, we have that over here, dot radius. For I, comma, character. So we're going to go through that table, and we're going to do damage to them. Self.damage. So this is just getting their humanoid. Gonna deal that amount of damage that we specified up here. That's all it's doing. And then finally, we no longer need this mine object, so we're just gonna do that. Let's test this real quick. No errors that we can see. It's not running. Okay. We have a media problem. Let's find this problem. We'll isolate it, fix it. So it doesn't seem like that the touch event is running. So let's see. Let's make sure. Let's do some bug fixing 101 here. We're just going to make sure it actually gets this far simply by using print statements. Ignite. Oops. Okay, now let's test. So what it should do is it should say all those print statements I've had to make sure it actually gets to that function. Okay, so none of them are actually being printed. So, I'm not sure what the problem is. I'm gonna quickly find that problem. Alright, so a few careless mistakes I made. Number one, params.filters descendant instances. I accidentally forgot an S here, so just put that in there. Number two, I was also kind of careless when writing this function out. All you have to do is type in find first child, which is A. I totally forgot that because before I was just typing in find first ancestor named model. No, we don't want that. We want to find one of type model. So fix that. And down here, I was also just setting I was setting them equal. That totally overrode those. These were setting I was setting these variables equal to the part. Do not want to do that. Set the parents equal to the part. Don't make those stupid mistakes that I made. So finally, I think there's one more problem, but let me just test real quick to make sure we have this all good. This should work, I think. Yeah, it works. See, I take damage from it. One thing we do need to do, though, get debris service. So debris service, what that does is it's basically a destroy method, but it will destroy a object over a certain amount of time. Delete that print. So we'll just delete these after a few seconds. We'll make it 3 seconds. And by the way, you don't need these enabled if you're using emit. The what's it called? These particle emitters. If you're using the emit function like I am. So I'm gonna open up the properties and disabled. There we go. Let's test. And I'm gonna walk over it. Take damage. No errors. Seems to be working fine. So now what I should be able to do, I should be able to duplicate as many of these as I want. And they should all explode. Let's just try. Gonna walk into it, take damage. Yep, they all work. Perfect. And there's one more thing I want to show you before I end off this tutorial. I'm gonna add one more of these, and I'm gonna name it Supermine. Let's go, Supermine. So I'm gonna make this a different color. So you're gonna take damage, a little bit more damage from this one than the others. This will be a red mine. Stay away from the red ones. It will destroy you. So what I'm gonna do is I'm going to actually assign this. By the way, I'm back in the script underneath the mines folder. I'm going to assign this to a variable, and I'm going to say mine object. We'll name it that. If mine.name. So we're just gonna check if the name is equal to Supermine. If the name is equal to Supermine, then let's just give it some arbitrarily large values, which will do a ton of damage. I think will be cool. So let me see, what should I do? Let's make the size of the explosion. Let's make it like 10. 10's a pretty large size. And again, these I have all in here. And what else could I do? I can make it a really large radius if I wanted. Let's make it deal extra damage. Equals 90. Alright, this should do 90 damage, and it should almost completely kill me. So, that's cool. Let's try it. Oh yeah, that just almost one-shot me. Yeah, so that's how mines work. And this is only possible, really. Like, if you think about it, if I wanted to do this without object-oriented programming, I would have to have a script underneath every one of these mines. Do you know how absurd that would be? Can you imagine how many lines of code that would be? Meanwhile, all we have is a module script, 95 lines for all of these mines. Hey, that rhymes. Oh my gosh, that was that was a nice, super nice rhyme. Okay, so yeah, that's what it does, and I think that about concludes for the tutorial. Like I was gonna say, I'm going to show you where if you go to your toolbox, go to plugins, and type in emit. Let's see if it shows up. Here it is. Mine is called Particle Emitter V2 by OzzyPig. Make sure you get the right one. So that about concludes it for this tutorial, guys. This was actually a super fun one to make, and it did take time to actually create these mines, create the function. So if you guys like the content that I'm putting out, want more tutorials, please leave a like and subscribe, and have a great day.